Let's discuss the extrema of a function. The extrema refer to the maximums and the minimums, or the maxima, maximums formally, and minima referring to plural of minimum. So we can have two different types of maxima and minima. We can have local or global. Local also called relative, global also called absolute. And so let's walk through what these are referring to. And to best do that, I'm going to do it with a picture. So I'm not even going to bother putting on an axis. I'm just going to put it kind of in free space here. And so in this picture, we clearly see that there are some highs and some lows. So let's start with the highs. I see this point right here appears to be higher than any of the others. If I look side to side, that is at the top. This point is also pretty high. It's not the highest. There are clearly infinitely many points that beat it. If we were to just scan over, see all these points beat it. And then this one here is also pretty high compared to its immediate neighborhood, but not nearly as high as these others. So all three of these points are some sort of maxima. This one right here, because we said it was the absolute highest, we can call it either the absolute maximum or the global maximum. I'm going to call it the global. It really doesn't matter. And I'm going to just say max for short. However, those other 2 points do win out in their respective areas, and so they are called local maxes. Now, this global max is actually also a local. All global are always local as well. Now, if we think about why that was true, let's think about kind of a real, more hands-on example or something we can think about a little clearer. Let's think about maybe being the wealthiest person in your neighborhood. If you're the wealthiest person on your street, that just means you have more money than the people directly around you. So this point is higher than anything around it. However, that's not to say if you go over a few streets or another town, there's going to be somebody richer there. But that person, there's maybe somebody that's richest on that street, and they might be richer than the richest person on another street, or they might also be poorer than the person on the next door street. But once we find that richest person in the entire world, on the entire globe, we can safely say that they are the richest person also on their street. So if you're the richest person on your street, we can't say that you're the richest person on the world, but if the richest person on the world, you can say that you're richer than anybody on any other street. So for instance, if you're the richest person on your street, there's still Bill Gates hanging out there, whoever's the richest person right now. They are going to have more than you. They're going to be at a higher point than what you are. Same idea with the minimums or the minima. We can have the absolute lowest, and so that would be what we call the global or the absolute. And that has to in turn be a local. And then we can have other relative or other local as well. So when we say local, what we're doing is we're looking in its immediate vicinity. We don't care how small we have to drive that vicinity to be. Just can we find somewhere in that area? It doesn't matter how small. So even if it's just for the smallest bit of time. So if we have the smallest little dip and then it keeps going up, that is still a local min because just for slightly of a second, it is the lowest. Same thing could work for the maximum if it's just ever for the slightest second, or for like that point or that point. Either of those would be the local maxes. It doesn't have to be a great deal of time. So if we want to make it more regional than even your street, I did the money example a second ago with streets. Could say, hey, I'm the richest person in my house, and that's not even true for me. My wife makes a lot more than me, so I don't get to be the max in any situation. I guess I make more than my son, but beyond that, I'm pretty much a minimum in my household. So let's bring this back into some equations now that we have the idea of what's going on. So when we're studying equations, we need to consider where these points might occur. And so clearly endpoints always have the potential to be a local or a global. We've seen on one end it's a global, on the other end it was a local. And remember global also being local. However, we have some other points that could also be globals or locals, and those occur potentially at turning points. So that is one point we need to consider, turning points. And what we've seen is those turning points occur when the derivative is 0. So I need to find when the derivative is equal to 0. I need to consider those points to be my local or global extrema. However, yet another picture we haven't talked about, if we have jumps or if we have holes or if we have corners, cusps, those are also points where we might see extrema. And so in addition to my endpoints, in addition to my points where my derivative is equal to 0, I need to consider points where the derivative is undefined. And that brings us to our next term, critical points. Critical points are points at which the derivative of the function f of x is equal to 0 or is undefined. So critical points could be undefined points where the derivative is undefined, corners, cusps, or just non-continuous points. And also critical points could be those points at which the derivative is equal to 0. So when we consider any sort of extrema, it doesn't matter if it's absolute or local, we need to consider the critical points and the endpoints. So let's look at an example and let's find all of the extrema. Let's take the example, find all extrema for f of x equals negative 3x to the 2/3 power on the interval negative 1 to 1. So we're given endpoints, but we also need to consider endpoints internal to the given endpoints, meaning are there any endpoints caused by discontinuities? Do we have any jumps or any holes or anything like that? And so if we look at this function, x to the 2/3, that's continuous from negative infinity to infinity, so there wouldn't be any holes, any disconnects there. So we only have these endpoints that we need to worry about. In addition to the endpoints, we also have to look for critical points. And to find my critical points, I need to find a derivative. So let's find the derivative of our function. So we'll have negative 3 times 2/3, that's going to give me negative 2, x now to the negative 1/3 power. And so now we need to think about when this thing is equal to 0 and when it is undefined. So let me set my function equal to 0 for starters. Really might be a better idea to think about when it's undefined. So when would this thing be undefined? Well, now because this x is in the denominator, if x is equal to 0, that's going to give us an undefined value. So I know one of my critical points is 0. And the reason I like to start with that is because I might solve this and I might get what I believe to be a point at which it's equal to 0. It's really undefined. It doesn't really matter. They're both critical points, but sometimes those undefined values are a little bit easier to see. So I'm going to move my 2 over. I'm going to get 0. X to the negative 1/3 is equal to 0. Of course, there's no point at which that can occur because that x is in the denominator, so there are no solutions to that. However, I had already seen that that 0 was a critical point, so even though it's kind of looking like it's going to set up to be equal to 0, we couldn't have that 0 because that is in the denominator. It was the undefined value, so we know we have a critical point at 0. Now what I need to do is I need to set up some sort of way to measure what are the mins and what are the maxes, where are the highs and the lows. And the easiest way to do that is just list off all your endpoints and critical points. And I think it's easiest if you put them in order. Put them in ascending order. That's going to make it easier to see when we're going up and when you're going down. If you just list your endpoints and then your critical points, you're going to miss when it's actually turning. So now that I have these values listed in ascending order, I'm just going to evaluate. So I'm going to look at what is f of 1. So we have negative 1 squared, that's 1. The third power of it is still 1. Then multiplying by negative 3, we get a negative 3. Next, f of 0. 0 squared is 0. Third power of 0 is 0. Times 3 is 0, or negative 3 is 0. And finally, f of 1. Well, it's going to be the exact same as the negative 1 because it's being squared. So we have our three values, and so if we think about what we're doing here, right, if it helps, you could even put them on a little sketch, -1, 1, and 0. I don't have to make it super accurate. I don't have to have all the bends correct. Just getting the positions. So at -1, we were at -3. At 1, we were at -3. And then at 0, we were at 0. So clearly, we're going up, and then we're going back down. So that means that this point here, 0, 0, is a global max, which means it also has to be a local. If you're a global, you're also a local. And then these points here at -1 and 1, those have to be global/local mins. So another way of saying that, let me write it out slightly differently because we do have the pair of them. The global min value is -3, which occurs at -1 and 1. It isn't possible to have two different global maxes or mins, but it is possible to have one global min that occurs in two different positions. There can be two people that have exactly the same amount of money, yet they live in two different places, right? They have the exact same amount of money, $1 billion. I know Bill Gates is richer than that, but $1 billion just happens to be two different people. So when we're talking about globals, there can only be one of them, but we're talking about the y value. It can occur in multiple positions. So we have only one global max and only one position for it. We have the one global min, two different positions for it, but we've listed out all of our extrema here. So anytime we are looking for the extrema, we are paying attention to what are our endpoints, what are our critical points. In critical points, we need to know when is our derivative equal to 0, and also when is it undefined.